Radiographic interpretation of welds. The radiographer should be able to interpret radiographs and be a high-quality radiograph producer. The radiographic interpretation process can be divided into 3 steps: 1. Detection, 2. Interpretation, and 3. Evaluation. These steps all rely on the visual acuity of the radiographer. Visual acuity refers to the ability of an individual to recognize a pattern spatially in an image. Radiography can be affected by lighting conditions in the viewing area and experience in identifying various features. I am creating this video to help students understand the defects you can find in weldments and how they will appear on a radiograph. Please like and subscribe to my channel to notify you if a new video is being uploaded. Discontinuities. Discontinuities are breaks in the standard structure of a particular material. These interruptions can occur in the base material, weld materials, or heat-affected zones. Defects are discontinuities that do not comply with the specifications or codes used to control and invoke an inspection. General welding failures. The following discontinuities can distinguish all types of welding. Cold lap. Cold lap occurs when the weld filler material does not fuse properly with the base metal or previous weld pass materials. Interpass cold lap. The arc fails to melt the base metal enough, causing the slightly molten puddle of weld filler metal to flow into the base material without bonding. Porosity. The result of trapped gas in the metal is the porosity. On a radiograph, porosity appears in many different shapes. It can appear as irregular or round spots, but it is most often seen as a single dark spot or cluster. Porosity can sometimes appear elongated and even have a tail. The gas is trying to escape from the metal while it is still liquid. It is known as wormhole porosity. Cluster porosity. Cluster porosity occurs when flux-coated electrodes become contaminated by moisture. When heated, the moisture becomes a gas trapped within the weld. The radiograph will show the same porosity as a regular one but appear in clusters. Slag inclusions. Slag inclusions are non-metallic solid materials entrapped within weld metal or between the weld and the base metal. Slag inclusions are visible on a radiograph as dark, jagged, asymmetrical shapes in the weld area or at the weld joints. Incomplete penetration or lack of penetration. Lack of penetration, LOP, or incomplete penetration, IP, occurs when the weld metal fails to penetrate the joint. It is one of the worst weld discontinuities. A lack of penetration can allow a stress riser to occur, which may lead to a crack. On a radiograph, a dark region with straight edges and well-defined borders appears to follow the land face or the root face through the middle of the weldment. Incomplete fusion. An incomplete fusion is when the weld filler metal fails to fuse with the base metal properly. The situation is usually visible on radiographs as a dark band or bands oriented along the weld prep or joining area. Internal concavity or suckback. Internal concavity, or suckback, is a condition where the weld has contracted and been drawn into the weld root as it cools. It looks like a lack of penetration on a radiograph but has irregular edges. The line is also quite broad at the center. Root undercut is an erosion of base metal near the root of a weld. It appears in the radiographic image as a dark, irregular line offset from the center line. The undercutting process is less straight than LOP, as it does not follow the ground edge. External or crown undercut. External or crown undercut is an erosion of the base metal next to the crown of the weld. In the radiograph, it appears as a dark irregular line along the outside edge of the weld area. Offset or mismatch. Mismatch, or offset, are terms used to describe a situation where two pieces of material are not matched. The welded together is not aligned correctly. The radiographic image shows that the welded together are not correctly aligned. The difference in density is noticeable between the two pieces. The difference in density, the difference in thickness of the material, is responsible for the dark, straight line. The difference in the material thickness is the cause of the dark straight line, the failure of the weld to fuse with the land area. Inadequate weld reinforcement. Inadequate weld reinforcement is part of a weld in which the thickness of the weld is insufficient. The thickness of the metal deposited is smaller than that of the base material. It is easy for radiographs to determine if the weld metal reinforcement is insufficiently reinforced. The image density will be greater, darker, in the area suspected of being inadequate. Image density of the base material. Excess weld reinforcement. Excess weld reinforcement is part of a weld where weld metal is added, exceeding the limits of engineering drawings or codes. The appearance on a radiograph shows a lighter, localized area in the weld. Visual inspection can easily detect a problem. Determine if the amount of weld reinforcement exceeds the specification, engineering requirements. Cracks. Cracks are only detectable in radiographs when they propagate in a way that causes a change of thickness parallel to the beam. Cracks appear as jagged, irregular, and sometimes very faint lines. Cracks may appear as tails, inclusions, or porosity. Discontinuities of TIG welds. These discontinuities are specific to TIG welding. The following discontinuities are unique to the TIG welding process. Aluminum is not exempt from this phenomenon. Stainless steels. The TIG method produces a clean, homogeneous weld. Weld that is easy to interpret when radiographed. Tungsten inclusions. Tungsten, a dense and brittle material, is used in many products. The electrode is used in tungsten inert gas welding. When welding is performed incorrectly, the results can be disastrous. The tungsten can be trapped in the welding. Radiographically, tungsten is more. It is denser than steel or aluminum, making it a lighter color. Radiograph with distinct outline. Oxide inclusions. Oxide inclusions can be seen on the surface. The welding of aluminum is a good example. Oxide inclusions have a lower density than chromium. The surrounding material appears dark and irregularly shaped. Radiographs can have discontinuities. Discontinuities of gas metal arc welds, GMAW, welds are prone to the following discontinuities. Whiskers. Whiskers are short weld electrode cable lengths visible at the weld's top or bottom surface or within the weld. They appear on a radiograph as light, wire-like indications. Burn through. Burn through occurs when excessive heat is used to cause weld metals to penetrate the weld area. Metal lumps can sag and create a globular appearance on the backside of the weld. These metal globs are called icicles. On a radiograph, burn through is seen as dark spots often surrounded by light globular regions, icicles. Castings, radiograph interpretation. Radiographic testing is primarily used to detect defects in castings. Castings are a product form that can negatively affect a product's strength. Casting is a form of product that has a negative impact on strength. Many defects produced by the casting processes are volumetric and, therefore, relatively easy to detect by this method. The casting process is responsible for these discontinuities. If properly understood, deficiencies can be accurately accepted or rejected. Suitable corrective measures and decisions. The radiographer must be able to identify the size and type of defect. It is because different defects will have other impacts on the performance of a casting. ASTM E155 standard for radiographs for castings was developed to assist the radiographer in assessing the flaws present in the component. The castings used to create the standard radiographs were analyzed destructively to determine the type and size of discontinuities. Here is a short description of the commonest discontinuity types found in reference radiograph documents. Radiographic indicates for castings. Gas pores or blowholes result from trapped gas or air. These discontinuities usually appear as smooth-walled, rounded cavities with a spherical or elongated shape. The gas or air trapped in the mold will not be forced out if the sprue height is too low. Blows may also occur when sand is too wet or too fine, or if the sand has a low permeability, preventing gas from escaping. High moisture content in the sand can make removing excessive amounts of water vapor from the casting challenging. Green ladles and rusty or wet chills, chaplets, and chills also cause blows. Here is where we end this video. If you find this video helpful, Please kindly like and subscribe to my channel for more videos. Thanks and see you in my following video.